Everybody. This video is like kind of almost a sequel to yesterday's video because we're going to be dealing with the same overall subject, which is test time scaling, but we're going to deal with it in a different way, and this in a completely different research paper. This research paper is called TAPS, Frustratingly Simple Test Time Active Learning for VLMs. And then so yesterday we focused 100% on a method with regards towards LLM models, with regards towards this test time learning. In this particular paper and this particular video, we're going to focus as it relates to video language models, and then very specifically with regards towards video within that. And then so that's what struck my eye within this. I have so I separate my work from my research right now all the time, but my work that I do is more and more on the video side, and then keeping ahead on that end. And then so I really like and dive into when I see research papers like this, right? When I saw the method yesterday, and someone actually brought it up as a comment, right? Which is the next step would be for diffusion models, right? And then for video models, and then the method that I was going over yesterday very much did intrigue me because of its possible application to video models, but I didn't actually understand how it could be applicable to video or vision language models in this particular instance. And then now, after reading this paper, I understand it. Their method is awesome. I've actually I can significantly improve their method, like very significantly, right? And that's no joke. I'll show you the code. I'll open source all of the code, etc. I know a lot of there's a few people they like to make offhand comments there's how do you know more than the researchers in this instance, or how do you know are you claiming to know more than the researchers in this instance? Yes, very much 100%. I am claiming that I have a better method than what is laid out in this research paper. Unequivocally, 1,000,000%. That is my claim. That is my statement, and I've done it before over and over again. This is the millionth time that I've done something like this. Yes, that is exactly what I'm saying. If you have further follow-up questions, please follow up. But so within this particular research paper, what exactly is this method overall? So let's just dive a little bit into the abstract, because once we dive into the abstract, I think you'll figure out, if you've been watching this channel, why this particular method is so cool to me. And then I'll dive deep into the innovations that I've made on it, right? So test time optimization enables models to adapt a new data during inference by updating parameters on the fly. Recent advances in VLMs have explored learning prompts as a test time to improve performance in downstream tasks. In this work, we extend this idea by addressing a more general and practical challenge. Can we effectively scale and utilize an oracle in a continuous data stream where only one sample is available at a time, requiring an immediate query decision while respecting latency and memory constraints? To tackle this, we propose a novel test time active learning framework that adaptively queries uncertain samples and updates prompts dynamically. Unlike prior methods that assume batch data or multiple gradient updates, our approach operates in a real-time streaming scenario with a single test sample per step. We introduce a dynamically adjusted entropy threshold for active querying, a class-based replacement strategy for memory efficiency, and a class-aware distribution alignment technique to enhance adaptation. The design choices are justified using careful theoretical analysis. And then they go through their experiments and their methods. And then again, so here's their methods, their algorithms. They break it all down. Nice research paper, right? And then so it's directly related to images, right? And then so image augmentation, image classification, etc. And then so here's their data set, and and then here's their results that they're able to get on different data sets with regards towards their method overall. Algorithm number 2. Experiments, and then their overall results, right? And then so their overall results on one of their their best benchmark is 95% on one of the tests, the most simplistic test, but you can see it goes down to as low as 25%. 67% is their average overall, so 67% average. And then you can see here their method here is advancing the board here, but I mean it's within the statistical margin of error overall as to like what their method is bringing to the table overall with that particular result. I'm just highlighting that overall and pointing that out. Like if you dive deep into these results, like it's not they're going from 63% on the baseline to 67%, which like I mean again, we're gonna get it higher than that, like a lot higher than this. So let's go ahead and dive into the collab notebook here, and then so. Overall, like if you haven't figured it out yet, right? Essentially, what this method does is it creates what they call an oracle at test time in order to guide the model and guide the prompt and like essentially like guide it through the latent space better. Cool. Like I like that overall because that's a lot of my frameworks, right? Deal very specifically with that. And then so the very first thing that I did was I took their framework and I incorporated it into my base Swarm Queen optimize my Swarm Queen optimization, and then so that's what we're looking at here, right? And then so this is essentially like I took their method. So this is like test time Swarm Queen optimization is like what we're looking at here. So it's to me it's super cool overall, right? And you could take a video language model or a CNN in this instance. So mine works like it's just with image classification is what this is set up for and for testing, right? And then so with my baseline, like my very first result, you can see here, I'm getting 41% average accuracy and then 54% towards the end. So increasing accuracy towards the end, but still like these aren't great, right? 41% overall and 54%. This is a 10 category test, so coin flip accuracy would be 10%. So 41% accuracy is significantly better than coin flip accuracy, but 41% is still low. We want to get those numbers up, right? So next experiment that I do is I essentially take this one step further, and then I make that oracle like Zyra. Like I take the Zyra architecture, and then I build that out for again for test time optimization. And then the other thing that I do is I use the geometry aware Zyra model. So if you're not aware, what's essentially I've gone over this on my channel numerous times, right? Like so, and it's been proven out now in multiple different ways. I'm not the only one that goes over this, but essentially the models don't actually learn from your data set itself. They learn from an abstraction of your data set. And then that abstraction of the data set has a geometry that's associated to it. And that geometric pattern within the latent space is essentially how the model operates, how it learns, what it's learning off of, what it's doing, etc. Right? And then so what I do with the geometry aware models is I essentially just recognize that and optimize for that. So I say, okay, here's 10 categories of data and 10 labels, right? These labels are essentially a human construct. I want you to take that human construct of the 10 labels and then match that to whatever your geometry is for these 10 labels. Like maybe your geometry is 100% different than the human construct. Like maybe the AI construct is completely different math that I would never understand, fathom, etc. So, okay, cool. You take the AI construct and then map it to the human construct, and then let's take like measure the difference between those two and the distance between those two, and then essentially we'll play around within that space, and then that's what we'll categorize off of and train the model off of. And then within that, you can see here, we're getting final result scores of 76% accuracy as on average and 86% accuracy as our overall average for our last 200. But if you look at our first 200 were literally at 100% accuracy with this model. Like it actually started over training. So with this particular framework, it's a test time framework for image classification. You could also utilize this for diffusion, image generation, etc. And then this would be in lines and in like a good replacement for, like, for example, GRPO. And that's like very specifically why I'm interested in this method, right? So having played around with now, experimented with GRPO, I have a deeper understanding now of GRPO than probably 99% of the population. I guarantee 99% of the population and 99.9999% of the population as it pertains to GRPO and video language models and video generation. And the drawback to GRPO with video generation is it's just beyond computationally expensive, right? Like I've thrown like a supercomputer at it, and it's still like I can barely be able to get it to compute. And then so I've been searching for and wanting a method that would do exactly this, right? Where I can essentially take the same exact amount of compute that I would use for LoRa training, but then I can give it this beefier training and have it train itself overall, right? That's essentially like what we're getting at within this is a GRPO level training that I can do on the fly at test time and then utilize very little resources. So that's what has me overall excited about this method. It's like, to me, this is like GRPO, but not computationally expensive. And then so I see this as a huge game changer overall. Like, these frameworks are super cool. And as you can see here from my experimentation with this, the results check out. Like, this method works overall if you know exactly how, if you combine it the right way overall, basically, right? So I'll leave a link to both this paper and the Colab notebook. Again, I open source all of this, all of the code, all of the underlying framework here. So play around with it. If you figure out that it's super cool, then there you go. And if you like this type of content, please like and subscribe. Thank you very much.